Now we'll understand what are indifference curves. Now indifference curve shows all the points on the graph which are giving you equal utility. Now this is important, equal utility. So you pick up any number, any combination of x and y, it should give you equal utility. So the first thing which you have to draw, which you have to do in order to draw an indifference curve is that you have to fix that utility. Say you fix this utility at 5. So what will happen? You'll have to pick up the different combinations of x and y which will give you a utility equals to 5. Say if utility, say if x is equal to 5, what should y be equal to in order for you to give equal to 5? 1. Say if y is equal to 5, it should be equal to 1. If x is equal to 10, then y should be equal to say half. If x is equal to half, then y should be equal to 10. Say if x is 20, then y should be 1 by 4. If x is 1 by 4, then y is 20. So all of these combinations of x and y, they are giving you utility equals to 5. Okay, so this is say 5, this is 20. Okay, now half and 1 by 4 are somewhere here. This is 5, 10, 20. So 5 and 1 somewhere here. Okay, and it should be somewhere here. So if you join all of these points, it will give you this graph. Okay, it will not touch this x-axis. X-axis. This is something like a rectangular hyperbola, and remember this, that all of these points are giving you utility equals to 5. Okay, similarly, just see for min of xy, what is happening. See, we do not have to cram these graphs. Okay, we have to understand from where these graphs are coming. Okay, so if min of xy is equal to 5 is there, so what should be the combinations of x and y which will give you utility equals to 5? Say if x is 5, okay, then y should be greater than 5 for you to give you equals to 5. I'll tell you why. So in case of 5 and 6, which is the minimum? 5. So it is giving you utility 5. Similarly, 6, 5, 5, 5, okay, 5, 10, 10, 5, and so on and so forth. Okay, so the important point is that this is the point that is 5, 5 is the point where the lines are going to change. Okay, so suppose if this is 5, this is 6, this is 10. Okay. 5, 6, 10. So 5, 5, 6, okay, here. 6, 5, here. 5, 5, here. 5, 10, here. And 10, 5, here. So if you join all of them, okay, you join all of them, you will be getting this kind of a curve, and this is, remember this, that this is giving you utility equals to 5. This is giving you utility equals to 5. So this is an indifference curve. So these are the way your indifference curves are formed. So remember this, that all of these indifference curves, okay, all of these indifference curves, all these points, they are giving you equal utility. Okay, so all of these points. So what is most important for you to understand is that along an indifference curve, okay, consumer is indifferent between the several points. So if you being a consumer, if you are at this point, or you are at this point, or you are at this point, or you are at this point, you are at any point, all of these points are giving you equal utility, and hence you are indifferent. Okay, so all of the points, they are giving equal utility. okay, and hence consumer is indifferent. So this is what your indifference curve is. It's a locus of all the points or all the combinations of different goods which are giving equal utility to the consumer.